excuse me, with rounding and whatnot, it's time to take it a step further. And by step further, I mean doing math with our sig figs. Or another word for it, operations. With sig figs. I kind of feel like it's like a Always Sunny in Pennsylvania a situation. So we're gonna do math with this, dude. The game starts doing operation with sig figs. I don't know, I might be aging myself on that quote, but either way. Now, when I say doing operation with a sig figs, what does that mean? That means I cannot trust what the calculator tells me. Anytime I'm doing some kind of math in chemistry, I cannot just take whatever the calculator puts out for me and record that as my final answer. There's a reason for this in chemistry and all the sciences, actually, that we're going to always have to round it. Because my answer cannot be more precise than the least precise measurement. Now this is a bit of a change of pace, because if I sat there with my calculator and I typed in 10 divided by 3, I'm going to get an answer of 3.3 repeating. Right? If I take my calculator, let's go ahead and just put it to practice. See, Mr. Watson ain't just crazy. 10 divided by 3 gives me 3.33333, repeating all the way through infinity. Now the question is, which infinity is bigger? This infinity, or the infinity of number, or the possible numbers that exist between 10 and 12? Which infinity could possibly be larger? That's a crazy thing that, for those who do get into physics and those that are higher levels of mathematics, is when you start realizing that all infinities aren't the same size. Whew, that's going to be a wild ride for you. So, prop my door open. Fix that real fast. Good job. No, we're not going to record that as 3 repeating all the way into the end. We are going to find out today if that was a calculation that I had to do in chemistry class. I would record that answer as just 3. There are reasons for that, and we're going to get into those. I'm going to leave this up here for a quick second so you guys won't get a chance to record it. Answers cannot be more precise than the least precise measurement. So just a heads up on the printout that I gave you guys have already done 5 through 13. Your homework right now is just going to be 14. This is what's going to be our homework. We're going to pick a couple questions from it, and we're going to work on them together. But this is going to be the meat and potatoes that you're going to get done for me before next class. Now, Mr. Wiseman, you've lost your mind. I went to Algebra 1 class, I've been to geometry, and my teacher just tells me whatever the calculator tells me is the right answer. Why are you telling me things are different here? Because, again, our answer cannot be more precise than our least precise measurements. We have two main rules for rounding. There we go. And we are going to need to become familiar with them. So rules for rounding operations. Now, good news is there's only two rules, or else it would be singular. Rule for rounding operations. We think of the rules with plus and minus, so addition and subtraction, and multiplication and division are going to share rules with each other. Now, to make things easier, the one that we're going to do the most of, multiplication and division, has the easiest of the rules. The answer will have the same number of sig figs as the factor with the fewest sig figs. So let's see this in practice. Let's say I have a calculation. In my calculation, I have 22.0 liters divided by 3.0 grams. So I'll put that in a calculator and tell me, what did I get? I'll get an answer of 7.3333. That just keeps on repeating. Now I think I have to be careful with my units. So in this situation, my units would be, because liters can't be divided by grams, liters over grams. Not the biggest thing we need to worry about, but I need to worry about the sig figs here. In my question, which number has the least amount of sig figs? 22.0 or the 3.0? Was it? 3.0 is the least amount of sig figs. How many sig figs do we count on this one? 2, right? 1, 2. I go back, I take a look at my other number. I count 1, 2, 3. That tells you my final answer cannot have more than 2 sig figs. What's my final answer going to be then? Was it? No, say it aloud. 7.3. 7.3. Because.
I'll just make sure you shut the door after you.
If all I can have is 2 sig figs, I always start counting my sig figs from the left-hand side, work my way over. 1, 2. I draw my rounding line. Is this 3 big enough to push this 3 to a 4? No, so my final answer, 7.3 liters divided by grams. That's our easiest one. I'm just going to go by whichever one. I'm going to make sure that my final answer has the, least amount of sig figs as the factors in my question. Sorry, that seemed a little bit weirder than I was saying it out loud. My final answer cannot have more sig figs than my smallest number. My smallest number, right? Sig figs wise. I don't have 2 sig figs here. My final answer can only have 2 sig figs here. If I had, let's do another one. .45 times 0.001. So that's grams, and we'll make this grams as well. So we'll put that in a calculator, tell me what they get. What'd you get?
0.00345.
0.0345 grams squared. How many sig figs does my final answer have? I vote for 3 sig figs. Do I hear another vote? How many sig figs my final answer can have? 1?
I'm not sure.
Well, be sure. Come back to me. Samantha, how many do you think we should have? Got another vote for 3? Fabian, what do you think we should have? Got a vote for 1? All right, so I thought it was on the tiebreaker. I got to find somebody in the back. Let's pick on. Mariana, how many sig figs is my final answer going to have? Oh, so 3s unfortunately did win, but unfortunately the correct answer is only 1. Number of rules, guys. Rule 1 is I circle all my non-zero digits, right? 1, 2, 3. There's 3 sig figs for 3.45. 1 sig fig for 0.001. Rule 2, I count my non-zero number. I count my trap zeros. I have no trap zeros. Rule 3, I count my trailing zeros. If there is a decimal place, there is a decimal place, but no trailing zeros. And then 4 was that I take all my leading zeros, so any zeros in front of non-zero digits, in front of my number, and I cross them out. I only have 1 sig fig to round my answer to. Is the 4 big enough to push my 3 to a 0? No. That's my final answer. So I've got to combine a couple skills. 1, I'm combining my counting of sig figs, and I'm combining my rounding of sig figs. Instead of me saying, hey, you need to round at this number of sig figs, we're going to see, we need to count how many sig figs are in my question. We need to round to that many number of sig figs. But it's a start. It's a start. Today's only day 1, right? This part is, I will say this, you're going to do a lot of math, multiplication, and division when it comes with sig figs. We're going to spend another day on this, just going over it. So if we're not getting it quite today, I mean, we just took a quiz. So we may be a little burnt out. So we're getting towards the end of the day. It's not the end of the world. Today, right now, we're crawling through the information. We're getting what those rules are. We got the rules for one. We got to get the rules for the other. This one we're going to use a lot more of. This one may be the easier one. It depends on who you are. For addition and subtraction, the answer carries the same number of, give me a second, person on my door, decimal places as the number with the fewest. Push that up so you guys see a little bit better. Multiplication division, I'm counting, my answer is matching the number of sig figs. When it comes to addition and subtraction, I'm matching the decimal place. So a little bit different. One I'm counting sig figs, the other one I'm looking at decimal places. Alright, let's do a little math. We did some multiplication division. Let's do some addition and subtraction. 16.4 liters subtracted 10 liters. Now you can do the math in your head for this one, or you can just shout out the answer. What's it going to be? 6.4 liters. Now, here's the thing. My final answer has to have the same amount of decimal places as the number with the fewest amount of decimal places. What's the fewest amount of decimal places? 6.4 or 10? 10 has how many decimal places? 0 decimal places. Is the 4 big enough to push my 6 to a 7? No. So my final answer would be 6 liters. Let's do a little addition. 8.5 centimeters, push it up a little more, plus 2.11 centimeters equals what? .61 centimeters. Which number has the fewest amount of decimal places? 8.5 or 2.11? How many decimal places does it have? 1. So how many decimal places can my final answer have? Is the 1 big enough to push my 6 to a 7? No. So my final answer would be 10.6 centimeters. Let's look at some of the questions from our homework together. Let's look at the rules of the homework. Alright, rules of the homework. We're going to solve the following problems. We're going to write the answer the calculator gives me. Then we're going to write down the answer with the correct significant figures. Don't forget your units. So my first column is just going to be whatever my calculator spits out to me, right? My second column is going to be how I round that answer. So remember, the calculator is not always going to give me the answer that I want. My answer cannot be more precise than the least precise measurement. Let's do A, 3.45 plus 3.4. 3.45 centimeters plus 3.4 centimeters. Like I said, you're going to take your calculator out. 3.45 plus 3.4 gives me a grand total of 6.85. So I'm going to write that in my calculator answer. 6.85. What's my units going to be? Centimeters. So. Now, I know that my calculator is mostly always wrong. How am I going to round this answer? Am I going to count significant figures or decimal places? Why am I counting decimal places? Because the operation's addition. How many decimal places can my final answer have? 1, because 3.4 only has 1 decimal place. 3.45 has 2 decimal places. Is the 5 big enough to push my my 8 to a 9?
Yeah.
Absolutely. So my final answer, and the answer with sig figs, 6.9 centimeters. So I'm going to go B. B, I got 3.43 centimeters minus 0.056 centimeters. Now we can punch this into a calculator. 3.43 minus 0. Catherine, thank you for joining us. Welcome back to the land of the living. Oh, I think I did too many zeros. I did too many zeros. 3.43 minus 0.056. There we go. All right. So, my unrounded answer, I get that straight from my calculator. 3.374. What's my units? Centimeters. Remember, always carry your units over. How many? So before I ask how many of what, are we looking for sig figs or are we looking for decimal places? I'm looking for decimal places because what's my operation? What is it? Why am I looking at decimal places? Because I'm doing subtraction. There you go, gang. So, how many decimal places can my final answer have? How many, gang? 2. It's 2 here. 3 here. So 2, 1, 2. Is the 4 big enough to push my 7 to an 8? Nope. So that means that my rounded answer is 3.37 centimeters. Let's do one more for good measure. You know, now I've got a couple of them. Let's do Let's do 45 grams. F. Let's do 45 grams divided by 8.345 meters cubed. What is the answer you get when you punch that into your calculator? So, yeah, it just keeps going on, right? So look back to F. 5.392450569 grams over meters cubed. Oh well. Am I looking for sig figs or decimal places with my answer here? Why am I looking at sig figs? Because I'm using division. What's my smallest amount of sig figs? Factor with the smallest amount of sig figs.
0.
What?
Oh, wait, no, I'm getting 2. Okay.
2, right? So look at 45, that's 1 sig fig, that's 2 sig figs. How many sig figs are in 8.345? 2 sig figs over here?
4.
There's 4 sig figs here. 1, 2, 3, 4. So the final answer can only have 2 sig figs. 1 sig fig, 2 sig figs. Is the 9 big enough to push my 3 to a 4?
Yes.
My final answer is going to be 5.4 grams per meter cubed. So we got about 6 minutes left in class, 7 minutes left in class. You can type in all of your calculator answers right now, knock them out the way, and then later come back and round them for homework. And that's how we're going to wrap up today.